Alright, let's get started. In previous video, we know that m tell us how inertial property in our motion. For example, if we have force as equals to ma, if we have lower acceleration but higher mass, we will have equivalent value force for lower mass or smaller mass but with higher acceleration, which means that m is an inertial property in our system. This inertial property leads us to definition of momentum too, but this property only explicit for translational motion, which is denoted for linear momentum. Now, we recall that the kinetic energy because of rotational motion as this which continuous rigid body, and we assume that the system of rotation axis is on central mass axis. But now we interest to this inside integration term, which is this dot product will lead us to form as this vector by using triple product for scalar and vector, and by some manipulation in algebra we will get the result as in blue like this. Before we continue, remember that vector in previous video too can be represented as matrix like this. So then in 3D we have R vector as a column matrix and so on for W vector, which for first term we can rewrite this as matrix multiplication as this. But before we continue, I defining this multiplication of matrix as RT multiplied by R, which equals to the magnitude R squared, which this T is about transpose or operation that if we have R vector just like this and then the transpose is you switch row to column and column to row and so on, which for R vector we will get the result as this. The next term we will get this, which by property of dot product I can switch R to W or W to R, which by transpose notation I can rewrite the characteristic as this. Now if you see the middle of this matrix multiplication, this thing will result to matrix as this. And I rewriting by like this. And now I will define the I capital matrix, which the entry is only in diagonal, which off diagonal is 0, or known as identity matrix. By scalar multiplication with lambda, we will get that each component of matrix is multiplied by lambda, which in this identity matrix we will have lambda only appear in the diagonal. So by some simplification, by using linearity in matrix multiplication, I will have this middle term of multiplication known as tensor of inertia, which remember that this R is position from rotation pivot or rotation axis. For confidence, I define a new matrix as I double arrow like this, which equals to this integral or known as moment of inertia in tensor form. This tensor create analogy, which in translation we have m as inertia parameter, but in rotation we have I double arrow as inertia parameter. Now we have this, and notice that R vector is position from pivot or rotation axis, not necessary from central mass, which if I has this rigid body system with central mass here, R capital vector from origin point, then if pivot or rotation axis as this dashed line, which rotation just like this, then R vector like this, which always perpendicular to rotation axis. In our first assumption, because the rotation matrix is on central mass, this leads us to R vector is equals to rho vector, a special case where central mass is a central of rotation or in pivot, and this is not necessary as general condition. And by using characteristic that magnitude between R capital and R vector as a constant in time, which by this illustration where central mass is not a center of rotation or have distance as a vector, then we define a new characteristic that rho vector. Now we can denote this as r vector plus a vector. As we replace r vector before with rho vector, we will get this result. And by using mass moment for rho vector, which is a vector independent with respect to mass distribution, so the final result will lead us to form just like this. And now we will have the first term as original moment of inertia used in our system, but the second term is additional moment of inertia after shifting rotational axis from central mass as a vector. This result commonly known as parallel inertia theorem. For closing, this leads us to new definition of angular momentum. L vector will equals to I double rho multiplied by omega vector, which omega vector is mass distribution independent as parameter of rotation velocity. And the total kinetic energy, we can rewrite the before result as this tensor multiplication with respect to pivot and not necessary to central mass. And for closing too, I will send these questions. What if the first derivative of magnitude of rho is not zero? Which I will leave for audience. That's how the moment of inertia derived. I hope you enjoyed the video. If you like this video, be sure to share and subscribe, and see you later.